Hi guys, I am back again. I am back again for another post contest discussion without fixing my sleep probably. So, see, I want to become the best post contest discussion that Indians can have, okay? And for that reason, I'm doing Codechef too. Do you guys get that? Mm, so, yeah, let me share my screen or let me create some. At least I should have washed face maybe. Mm, 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 mm. So, I have this yesterday's folder. Let me go to new folder. I should not shout because it causes disturbance, right? Is internet fine? Is internet fine? Is clarity fine? Damn, more than 10 viewers already. Is clarity fine? Am I audible? Am I audible? Yeah, I'm audible too, right? So let me open Codechef. Okay, this was yesterday's struggle. Yesterday's struggle it was. Let's see if it works. Codechef. I struggle to find my username itself on Codechef at times. So now how to give that Codechef contest? Was this that? No, it's upcoming. See, they have sent me an email telling if you buy this, we will make you red or something. I'm red, I guess. I'm just 6 star. Should I become 7 star? Maybe I should. Maybe I should become 7 star. Do we have any one? This is one. No one gives coach F. That's why I hope it finally got connected, right? It finally got connected somehow. Yeah, let's hope it works like this. I think the problem is internet is okay here, but then for streaming it's being bad, I guess. For streaming. Because it needs continuous internet, right? Because whenever I run this, it shows okay internet. But then it's bad at sometimes, good at sometimes. So let me share my screen. Guys, let's read problems. Okay, coach of problems, let's read them. I think this is the contest, right? Rated till 5 star. If it is rated only till 5 star, how the fuck can I give them? When does division one contests happen? So these are the problems. We have division one greater than or equal to 2000, but okay, let's say this can get the skills to land your first job in tech. So I'm sorry for troubling you guys. I'm sorry for wasting your time too. Let's hope we can do things better next time. I haven't planned this, right? So let's read this problem. The score of a let's try to read this problem and understand this problem, okay? Read the problem. and understand the problem. Okay, first step, let's read the problem and understand the problem. That's what we do. Okay, guys. Uh, so the score of an array B of length m defined as, will this work here? Damn, it's working. So the score of an array B of length m is defined as follows. Let P denote the number of pairs I, j such that Bi equals to Bj. Score is m minus P. It's length minus number of pairs it seems. Okay, this is the score. So number of equal elements, number of pairs that are equal is getting subtracted from the length. Okay, that's what a score is it seems. You're given an array A. Your task is to compute maximum score across all contiguous subarrays of A. That is to compute the quantity this. So the problem is simple. The problem is obvious. The problem is direct. It's not like constructive. Okay, you have to compute something in lesser complexity. That's the problem, right? Did you guys get the problem? We should just compute something over all subarrays. But to compute it in often, you probably need a simpler solution than brute force, right? And then you have to prove to that this is optimal. So your question is, you have to prove to that whatever the method you do is optimal, right? Your question is not trying to get some random things out of here. Maybe let's try to make some small observations. What if all are distinct? If all are distinct, what if all are distinct? To understand the structure of the problem a bit, okay? Because these things will be also included in our final solution, right? If all are distinct, p is 0, right? There is no pair at all. If all are distinct, p is 0. Like the video, guys. I know. Then answer is n. If all are same, then answer is if all are same, then answer is we want to maximize m minus p, right? We want to maximize m minus p. Then answer is then what is the answer? Then it seems weird, right? If all are same, if you take L things, it is L into L minus 1 by 2, which is minus, which is L into, I'm taking L common out, then it is 3 minus L by 2. Am I right? And 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 its max value is at L equals to 1 or L equals to 2, which is 1. So we can say few of these things, right? We can say few of these things. So 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 this this function minus p itself, we can split this in terms of we can split this in terms of frequencies of the characters that are there, right? If some value comes v times it in our subarray, its contribution is its contribution is what is its contribution? V minus its contribution is v minus v into v minus 1 by 2. So this says something about the structure of the problem. We don't want its contribution. Why? Its contribution in M is V. Its contribution in the other thing is this, right? Its contribution. But then, so this says for anything, we don't want that to be too many things. But then, so anything occurring only once is beneficial for us. Anything occurring once is beneficial. But then, if you have too many ones here, okay, sorry, too many ones in the sense too many distinct things, and then you have something same, okay, even though this same is bigger than one, maybe again you're having distinct elements. For that reason, maybe combining would be optimal. Maybe for that reason, combining would be optimal. Maybe, right? So now we have few things. We need not try for more small observations. These are good enough. So let's just see. Let's just see. Can we fix R and find the answer? Let's just see if having answer till I minus 1 gives us answer of I. Let's just try for this, okay? Let's say you have answer, you're maintaining something till I minus 1. Can you get answer of I? Can you get answer of I? So now you know that you're ending with this subset, right? You're ending with this subset. You're ending with this subset, right? You are ending with this subset, okay? Sabare. See, I can use brute force. I can use this logic itself that if this value contains more number of times than 3, then it's useless to take that. Do you guys see? Do you guys see? We got the solution. Did you guys see like we got the solution? How what I mean is, so we have to say, let's say we want answer. Okay, sorry. We didn't get the solution yet. I thought, okay, what I got was maybe I'll use this drawing thing. What I got was if you look at this value, let's say that is v at I, uh, answer ending at here would be, we need not take if there are more than v things. If v appears more than thrice, then including this is bad. We can just remove that for the last element. And then whatever the answer for this, it would not be better than answer for this. But then our DP is, we want answer of this too, right? We want answer of this too at some time. Because in our DP, once we know, okay, what's our DP? If a subarray is like this, how can we brute force all possible, or how can we write answer of this in terms of answer of previous things? So let's say this value is v. Okay, let's say this value is v. So now you have some v's. Okay, you have some v's previously. You have some v's. Can I brute force on number of v's? Can I brute force on number of v's? Not that easy. Why? Not just number of v's, but then we have this thing, right? We have this thing. Let's try for some time, guys. See, answer of this is answer of this minus frequency of v's, because frequency of v's affects adding this v. Okay, why? Let's, what am I trying to say is, let's say you're trying to see answer of something in terms of this by removing this. What happens? M minus p, you have removed 1 from m. You're removing frequency of v things. You're removing frequency of v things from this. So answer of answer of this can be represented in terms of answer of this for any subarray. Answer of this can be represented in terms of answer of this in this way, where it only depends on v comma frequencies of these things. Okay, but I don't think we can maintain for all frequencies of these. We cannot. I don't think we cannot maintain for each of these things. For each of the v's, we cannot maintain this. I think, right? I mean, if what am I trying to do is, if I have for all these subarrays, if I have something, what is that something? Answer of this minus this value plus this value. Answer of this plus 1 minus frequency. See, answer of this plus 1 minus frequency of v is answer of this. But then we want maximum of these things. But answer till here will vary with v. So maybe we need to use a bit more logic than what we are doing now. Okay, maybe we have to use a bit more logic. I mean, see, we are just looking if answer of this minus frequency of v can be stored for all these subarrays, and then we can get this in O of 1. But then we are not getting it like that. Okay. Do we have viewers? It's fine. Let's pause here. Let's pause 1 minute and then let's go to some other problem. Okay. It should be fine. We should be able to read more problems. Let's read this. Let's also read division one's next problem. Okay. Is this division one? Division one's last problem. What about division two? Okay, division two, it has only one solve. Set to median. Let me read this to them. There is no harder problem in rated things, so let me read this too. We have to read. We should not get scared. Okay. Let's think of this two in 1 minute. Okay. We have to get a clear proof, right? We have to get a clear proof. Let's think of this back, because answer of this minus frequency of v we want, right? Maybe we cannot just compute this. Maybe we have to make some better observations or some better statement about optimal. Maybe we have to say something better about optimal. Okay, one thing I can say is the end cannot have the frequency of end cannot be more than 1. This we can say. Why? If it is greater than or equals to 2, you just remove that and then this will be better optimal, right? Can not be more than 2, can be 1. In optimal, frequency of n can be 1. Okay, frequency of n can be 1. So if frequency of n can be 1, and if it is 1, see, dp ending here is different, dp ending till here is different, because if you want to extend the dp to the next thing using the previous ending thing, then you must find that. You must find that. So let me see this claim. You must find answer ending at r. Do we definitely do this? Do we definitely find this value? Let's think that. How difficult is it to find this value? If you're finding this value for all r, then we are good, right? But then if you're finding this, if you're finding this, can we do like binary search or something too? We'll think of that too. Can we do some binary search on that? maximum value we can get or minimum value we can get. See, we have unique elements taking this is good. We have unique elements taking this is good, but then combining those two will cost us this thing. Combining those two will cost us this thing, right? So it's like we have to combine sometimes, right? If so, it depends. If these number of x's here are less, then combining is good. Then combining is good. So we have that combining cost. But then the combining cost will grow exponential, will grow at a higher rate, right? That will grow at a higher rate. So let's think some more time. Should we use that fact that it grows a bit higher, like the other thing will grow a bit higher? Let's try a bit, guys, because uh, let's come back. Let's read this problem too. We made few statements. Let's come back again. We can solve this today. We can solve this in time too. You're given. You guys should be able to read problems well. Okay, reading problems is half the step. Okay, we can do binary search, but then after doing binary search too, see the structure of the problem. It's not that easy to say. Mm, it's depending on frequencies, right? It's depending on frequencies. Uh, if you fix this, as you go like that, more frequencies keep coming, and then as you go, let's say you fix some L, and then if you keep going, more frequencies keep coming. We want unique things more, or we want two things more. We don't want three or more things. Three or more things will give us negative cost. I mean, we cannot say random things to a bit, right? Because we have to say some useful things on that, and then only we can do it. Let's read another problem, okay? Let's read the problem and then come back here, okay? Uh, Maybe we have to use that it grows quicker, something else grows quicker. Maybe we'll find for each. See, now, 1 minute. I'm just checking messages. Let's read this problem too, okay? Subsequences. It seems define f of a, because see, we need not think more on a problem. Problem should go directly. If they're not going directly, we can wait and then we can try another problem, because thinking unnecessarily doesn't give us anything. Okay, thinking more doesn't give us most of the time anything. Try some other thing on the problem by observing something. Okay, so let's read this problem. Define f of a for an array a of length n as the number of elements x such that there exists an array c also 10. Okay, guys, read this problem too. We will solve this problem. Let me charge my phone. Along with me. Okay, this problem may be okay. Let's try to read this problem too. Maybe this can be more as the number of elements x such that there exists an array also of length n satisfying. So define f of a as for an array a as of length n as number of elements x such that there exists an array c of also of length n satisfying XOR of ai times ci equals to x. But this is 0 or 1. This is 0 or 1 means it's like a subset. This is equivalent to choosing some possible subsequence of A and then that's or x. The problem is direct, right? The problem is not that's not the problem. We are given more. Okay. So this problem is good, a bit good, because at least this has some initial work you can do. You can first work on f of a and then you can try to see what the remaining problem is. So guys, what does this say? You're given an array A of length n and a parameter k. Okay. Uh, am I audible? Am I audible? Let's think of this problem. Okay, now we are trying to read this problem, which is set to median. Sorry, not set to median. What are we trying to think? We're trying to think an easier problem, subsequences of subsequences. I thought the next difficult one. Okay, you're given an array of length n and parameter k. Construct an array B in the following way. Start with f of b as an empty array for all k length subsequences satisfying this. Append. So this seems shitty, but let's see that clearly. Okay. Construct an array B in the following way. Start with B as an empty array. For all k-length subsequences, append XOR of that to B. So we will have how many elements here? We will have 2 power nck elements in B. Okay. For all k-length subsequences means nck. Nck is number of ways you can choose k elements from n elements, right? Uh, so we will have nck elements in the B. Find f of b. Okay, so we have this is good. This should be done logically. I think now it's good, but the screen is gone, right? Everything's back, I hope. Thanks for bearing with these things. So let's read this problem. This seems a good problem, right? Guys, I wanna ask you. I wanna ask. Did you guys realize subsequences of subsequences? Sub is a good problem because you can work on it immediately after reading it. Right. I want other answers too. You can work on it immediately after reading it. Why? Because you have to logically deduce. You have to logically deduce that. Okay, given any array, we have some definition of f of a. Now, for all k and subsequences, you're able to compute f of b very easily. This is a very big array. NCK is very big, right? Because n is big, k is big, so NCK is very big. So you have to first logically solve the problem. Okay. So we have f of a for an array A to be number of distinct subset XORs you can get. So this is f of a, right? What do they mean? Number of elements x, right? But that doesn't. But that's nothing but this. Am I right? Is f of a simplification okay? F of a means equals to set of XOR of some subsequences. So it's number of distinct values of XORs, right? I think they have given that in question itself directly. In other words, choosing some subsequence of a, then that XOR should be equals to x, means all possible distinct XOR values of subsequences. That's what f of a is, right? Is that clear? That's clear. They complex that too a bit. If you guys notice, they didn't directly say you it's number of distinct subsequent XORs, but then they told you take a value. There should be at least one subsequence of that. They wantedly complexing it. First, you have to just do those shitty simplifications that you can instantly do. Okay, it's just nothing but number of distinct subsequent XORs. Okay, number of distinct subsequent XORs. Now, now number of distinct subsequent XORs. Right now, let's look at how this differs for k length subsequence. Okay, does this differ? Just look at this thing. If k less than n, you can always choose one index by choosing by choosing by choosing by choosing by choosing 1 minute. Let me be clear now now you should think of what is XOR of k things, again k things, again k things, up to so on. This is it, right? Because this is nothing but choosing some k things, and then this is again choosing some k things, and then this is again choosing some k things, up to so on, right? What is the restriction you have here? If the restriction is nothing, then answer of this is same as answer of this. But if there is some restriction, maybe there is some restriction, then you have to think what's the answer. Okay, if there is some restriction, you can choose one subsequence only once, but then there may be too many subsequences, right? There may be too many subsequences. See, I'm trying to represent one element as, I think, XOR of V1 XOR V2 can be represented as V1 k minus 1 same elements, V2 comma V2 k minus 1 same elements. In this way, maybe you can always get uh, V1 and V2, cancelling this and this. Maybe because now you're canceling this and this, but then you're able to reduce this 2k minus 1 things into just two things. Means probably maybe whenever uh, all the XORs that are achievable with even, yeah, but maybe I'll try later. Uh, why am I this problem too? So let's see a bit more. This one, right? Guys, we have to try. We can try. We have to try logically, little bit, right? Okay, for k and subsequence, what is the restriction? If k equals to 1, if k equals to 1, answer is f of a. So we must f of a2. We must find f of a2. How do we find f of a? F of a, we have 2 power 30 can be big. But then, if k equals to 1, let me write that down. Small observations. If k equals to 1, we must find f of a. So if k equals to n, answer is very restricted and is XOR of A. So here we have to think for a moment. Let's think 1 minute. So can we get all even XORs? So let's say sometimes it may not be possible to repeat things like this, right? Because in this case, it's not possible to repeat things because you cannot repeat two subsets. Okay, you cannot repeat a subset twice. Okay, that's the restriction you have. So sometimes it's not possible, but maybe for middle case it's always possible to get something like this and something like this, right? Because for middle case there are so many subsets involving v1, there are so many things involving v2, so maybe for middle things it's always possible. All the XORs, even values, even distinct values from a. So let's say you're taking from a even number of things like a1 XOR a2, a3 XOR a3, sorry, a4 or something, a5 or something XOR a7. So now let's say these are even. Let's say these are even. Are all of this achievable? Or all these even things achievable is one thing we can try to think, right? Or all of this achievable is one thing. But other than that, let's try some more time. I think what is f of a? Is it like some XOR basis thing? I don't know XOR basis. Is it standard? Like trying to find all subset XORs? Is that standard problem? Is this a standard problem? Maybe this is a standard problem. I don't know the standard problem, but maybe this is a standard problem. Should I Google that? Or should I think of this problem? All XOR subsets. Because we should also solve this problem, right? Okay, it's just number of all XOR subsets, right? It's just number of all XOR subsets. I think this is XOR basis. Okay. I don't know what is XOR basis, but let's guess. Let's guess what is XOR basis. Maybe any subset can be just formed using L distinct values. Maybe this is XOR basis. Like all these are like unique bits. Okay, that gives you the whole set. I mean, maybe that is XOR basis. Okay, so maybe f of a is 2 power L. Maybe this is true. So till here maybe it's true. Okay, so what am I telling is, we don't know, let's say we don't know what is XOR basis, but what it can be, if you try to think what it can be. I don't know what is XOR basis very well. I never studied it because I just skipped topics and I never learned anything. But let's try to think about that. If you try to think about that, is that internet? uh, Later, devil idea. But for now, let's think of this problem. I hope we have viewers, everyone that was there before. I hope they are staying. So see, guys, what does this mean is, because if you have two A's, both of them are unnecessary, right? Or something like that. So, what I mean is, let's say you have L distinct values and they can be used to get all possible subsets possible. Then, then, I mean, these are like the minimum. These are like the basic things. Like, I'm just telling, these things are like each of them corresponds to one different bit, let's say. It's like all these L different things are like some different bit. if if such a thing is true, then then we can say, because they are like a different bit, then we can say 2 power L is the answer. But how to, okay, maybe these L distinct values are nothing but XOR basis, but I don't know the topic. But maybe this seems okay. Do you guys agree? Do you guys agree? So even I don't know exactly what's XOR basis, but I know there is code. We can try to sometime think and try to form that mathematically, like maybe that requires more time to invest, but then if we invest, we will learn well. We will learn well. I know what I mean, we know what XOR basis does, right? I think it's like those are the only important elements. They can be used to get any other element. I think that's what XOR basis is. It's like the minimum length that can be used to get anything. I think code is simple once I have seen that. But then let's think a bit more. Let's try to think of K things too. If you must take K things, then what can you say? You must take K things. If you must take K things, so okay. Now we have XOR basis too. Okay. Let's say now we have XOR basis too. Now, and then we have this big thing. What all are possible is now we have to think. What all are possible? Mm, one idea I had was, whenever we have the even number of things, then it's possible is what I thought. Right? If we have even number of things, maybe I can just take, so like XOR can be represented as like this. Finally it can be represented of these distinct values. Okay. Finally it can be represented as these distinct values. Maybe these can be XOR basis elements too. Okay, if it can be represented like this, and these are even number of things, maybe we can just add same number of k minus 1 things to this, and then to this, and then to this, and then to this, up to so on, and then we have our answer. But then the k minus 1 things you add here, and then if you add them here, that's wrong. Okay, that's also right, but then you cannot repeat those k minus 1 things, because you can have k minus 1 things here and then you can have k minus 1 things here, but then you cannot use, among those k minus 1 you should not have a2, among those k minus 1 you should not have a1. This is the only restriction, right? Among those k minus 1 you should not have a1 or a2. So you need not use same k minus 1 elements here again. You need not use same k minus 1 elements here again. So 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 this seems, for most k you can use this same k minus 1 things, right? This k minus 1, why? Because if k less than n by 2, k less than n minus 2, for these two things you can definitely get uh, k minus other from n minus sorry k less than n minus 1. If k less than n minus 1, you have you have to choose k minus 1 things. K minus 1 less than or equals to n minus 2, right? Because k minus 1 less than or equals to n minus 2, you can choose n minus 2 other things from a1 and a2, and then you can keep them here and here. So whenever k less than or equals to n minus 1, all even things can be achieved. See, do you guys see that? Is that clear? Is that fine? Say, guys, is anyone there? Okay, so yeah, so what I meant was, let's say we can think of this idea, right? V1s or V2 equals to V1, keep K minus 1 things same. Because we have the restriction of choosing K things. So I'm trying to eliminate that restriction by keeping same things. Okay. Because that's the restriction we have, right? Choosing K things, we must choose K things, K things, K things up to so on. And then we have to see what all things are possible using like this. And these k things and these k things cannot be all equal. Okay, that's the restriction we have. So I'm trying to see if you can get all v1 or v2, like v1 keep k minus 1 other things same, v2 keep k minus 1 other things same. Now all these things are cancelled out, right? And then you have v1 or v2. So for that I'm telling, if k is less than or equals to n minus 1, it's possible. How is that possible? You can take a1, a2, you need k minus 1 things, and k minus 1 is less than or equals to n by n minus 2 means you can take something other than these two, not a1 not a2, there are n minus 2 other things, and you can take among them, you can take k minus 1 things, and then again you can place same k minus 1, so they both will cancel out, and then you have a1 or a2. So any even indices thing, anything that uses even number of pairings, you can get them. That's what I told. uh, So all even things will come if k less than n. If k, not if k equals to n. If k less than n, all possible distinct values that can be gotten from f of a using even number of elements can be gotten. Okay, just by using that logic of repeating things. But odd, can we get all odd things? Maybe not. Maybe not. Maybe we can. We don't know. We have to think. Okay. Uh, maybe we can look at k equals to 2, but let's not see right now. So now what's the restriction? Can we also get all odd things, like something that involves odd? Mm-mm-mm. This is one observation we can just say, but other than that, can we get all odd things? All odd things is a subset from initial array having some odd number of things. You can get 1 minute, guys. Let's think. Let's think for 1 minute. Uh, if you take k things and then mm, this is an easier problem, right? So maybe sometimes a guess would work. Maybe all odd also possible. Maybe people just guess that okay, if k equals to n, answer is fixed. If k equals to one, answer is two power l. Maybe people have guessed that. Okay, just because I'm spending time doesn't mean my ways are different, right? I try to prove. So unless I prove, I won't submit most of the times. If odd is also possible, then answer is just two power l for this and two power l for this, right? Answer is just 2 power L for this and 2 power L for this. Maybe now we have 2 power L minus 1, taking even number of these things. Maybe. But may not be that too. May not be that too. 1 minute, let's try for some more time. If we cannot get few things, we will be logically able to say this is impossible to get. Because we are using KKK things, this thing is impossible to get. We can also say that if some things are not possible, let's say if odd is not possible. So what all other odd things you can get immediately is one question you can think of, right? See, one thing maybe some other for all other odd things, maybe take, let's say you have odd things, okay, when events are A2 up to so on, some odd number of things. Now we want, can we just take three things and then write something like this? So I think we can take three things and then write something like that. We can take three things and then write something like that for all odd things. So if k minus 1 is even, see, now I'm trying to, for odd, because we can already pair even things like that, I'm trying to pair maybe three things, okay? A1 XOR A2 XOR A3. Can we pair these strings by adding few k minus 1 things on here? Let's try to think of that. Maybe we can add, maybe we can add uh, some value x, and then maybe we can add some value y, and then maybe we can add some value z, some value z, and then maybe we can add like that, and so on. If you keep doing like that, if you keep doing like that, where do we end up? If k minus 1 is even, this thing is k, right? If k minus 1 is even, we can fill it perfectly. If k minus 1 is even, we can cancel these things, all of these things. How if k minus 1 even we have 3 times of k minus 1 things, we have to fill these many, right? And then we have to fill these many. How many do we need? By 2, let's say. We want these many distinct values. Probably this is less than or equals to n minus 1, n minus 3. We need not use. I think it works because take any two things, they differ. Take any two things, we can even, okay, uh, if this happens, it works. And this probably will happen for sure. So this will definitely happen, right? Because this is 4 times n. This will definitely happen, right? Because this is just 3 times. So, and this is fine because we can just use this, and then these two cannot be equal because they are differing at y. They cannot be equal because we are not using a1, a2, a3. They cannot be equal. So I'm just want to make sure that this is not equals to this, and because we cannot repeat same k length subarray, right? So maybe even all these things are possible. Even all these things are possible. All all odd subarrays that can be gotten using all odd subarrays with size greater than or equals to 3 are also possible with k minus 1, with k less than n. If k equals to n, if k equals to n, we cannot proceed because this itself is not possible. So we cannot get all odd again. If k equals to n, we cannot get all odd again. Let's keep that. But if k less than n, this will definitely work. If k less than n. Why? Probably works because this is 4n, right? What is this? So k is less than n means k less than or equals to n minus 1 or k less than n. So I think this will probably work. Okay. So this means all odd things are also possible which are size greater than or equals to 3. You guys can see my ideas, right? I was able to initially say, can I use this fact? And then I was trying to say, okay, if even things can be paired, can we also cancel out odd things into this? But then we want k minus 1 to be even here. So guys, if you look at k equals to 2, k equals to 2, that corresponds to, means you are having two things, maybe a comma b, and then maybe some b comma c, up to so on. But you can always make these things as a comma c. So you can always reduce those into, whenever you have something common, you can combine them. So now you will be left out with a1 XOR a3, a5 XOR a6. You will be left out with even number of original elements. So maybe we can guess. So maybe we can guess that for k even, you can only get even number of, you can only get all the XORs from original array that uses even number of elements. Maybe this is true. Why for k equals to 2 it seems like, right? Guys, for viewers is too much. I will end this stream. If one question gets solved, I will just end this stream, okay? So we are able to use, maybe that's a guess. And once you guess it, you can prove it probably, okay? Let's just think of that. Let's just think of that. You have even number of elements. You have even number of elements. If you cancel out, let's say, let's just think of that. If k is even, okay, if k is even, let's Ravi Kumar, Ravi Kumar. If you look at, if you look at distinct values in k even length subsets. So let's say you have k even elements, and then k even elements, and then I have this. I have the proof in mind. I'm telling it clearly. Now we want to know, we XOR of this is number of elements that occurred x, ai occurred even number of times. This is XOR of x, right? ai should occur even number of times above. This is XOR of x, right? So if this is XOR of x, that means, if this is XOR of x, what does that mean? Now, because total is even, the total number of things are even, hash of s, number of elements in s is even, means you only get even number of sub even number of subsets. Now question is, can you get all of them? Yes. Why? We can use this logic to get all of them. We can use this logic to get all of them, and then we can use this logic to get all of them, and then we have proven that anything possible is some even number of elements. Is this clear? So you guys can see perfect proofs from me and then learn a little bit on proving. Okay, guys, who are all active? I will end the stream soon because if this problem is solved, I'll just end it. Okay, it's an easy problem, I know. So now what's left is k odd. Is everything possible? We showed that uh, everything of size greater than or equals to 3 is possible, 2 is possible. So is it possible to get one element is the question. This is the only thing that's left, right? Is it possible to get one element? Because my proof involved taking three things, right? My proof involved taking three things. Now the question is, can you get just two things? Is the question. Okay. Can you get can you get one thing is left? Ravi, Ravi, do you agree that can you get one thing is left? Because here we are using at least three things to use this logic, right? Right. So now, can I get one thing? What will I do? I will use, because we can cancel out any even number of things. I will use for one thing. What will I do? After this idea, after this idea, I will try neutralizing A2s or A3. I will try neutralizing them using A1, A1, and some other things, X up to so on, Y up to so on. Because A1 is not used here, A1 is also not used here. These are again new subarrays of length k. So as we can cancel even things, I'm trying to cancel them now. So this completes. Also, one is possible. Less than one. Less than one doesn't exist, right? Like all subsets, all non-empty subsets, I guess. Is zero always there? See here, the basis is 1 comma 2. That's why we have four things. I was just checking if empty is possible or not. I was just checking that. Just now I checked that. So now it's clear. See, let's say they're asking you to also output for any x that they give you to output k arrays, k distinct subsets, then we can solve it because we proved it more clearly, right? Then we can solve it. We know how to get single element, we have how to get even number of things, we have how to get odd number of things. Okay, let's solve this problem. Now let's solve this problem. Now the problem is, see, I am logically separating k equals to n. I'm not guessing. I'm logically separating k equals to n, and then I have proved for everything k less than n, I have proved things. For everything k less than n, I have proved things. Because we cannot do this thing for k equals to n. Sorry, this thing. We cannot do this thing for k equals to n. Okay. I've been very clear with my proofs, right? So you need not be this formal, but then you can sense that. Okay, in context, you can sense that. Okay, maybe even is possible, maybe odd is possible whenever k less than n. So I'm separating k equals to n. I need not make a wrong answer to know that k equals to n is separate, right? I wrote that before. But then k equals to n not failing, we'll also say, okay, what if k equals to n minus 1 also fails like this? But then I was able to say for k equals to n minus 1, we can get these things. I was able to see for what you can always get these pairings. Okay, so now where am I at? So where am I at? Uh, so so what has been simplified? K equals to n is this. If else, if k is odd, answer is 2 power L. Answer is f of a. If k is odd, answer is f even of a. Some g of a, let's say, means all possible even length sub arrays. So now, how to count even things? Can we use basis here too? How to count basis? How to count f of a? So now we have so now we have L special elements which can be used to form any AI. Any AI can be used using this. Any AI can be written using a subset of these things. That's what bases are. Okay. So now any even length subsequence, any even length subsequence can be written as B1, B2 up to so on BL, and then uh, and then some B3, B4 up to so on that, and then something else. But now if you see even length subsequence, right? So we cannot say anything. I thought I can say the total length of this is even, be, but then it may not be. May not work. I was trying to say even length subsequence will have even length. So I was trying to apply all the cancel out things. If you see, whatever finds is what I was trying to say. But then we cannot say if all of these things are even. We cannot say that. See, So we have done a lot of work. We have done a lot of work to convert. Yeah, I know that. I know that. We worked on converting k length to original array. Understood that. So now, if exists, I thought of taking two things from basis, and then I thought, A can have distinct values, okay? So anything can be represented as basis, right? So let's say, let's say, let's say. If AI equals to odd number of bases, then there is a subset. For some AI, then there is a subset. Why? Take this and take this, XOR of this and this. So Ravi, if that doesn't happen for any AI, then what does that mean? So odd, all AIs are odd bases means you have to you have odd things here, you have odd things here, you have odd things here. So you have even number of odd things. See, all even number of things can be reduced to odd number of things. Vedant Pandey, did you follow everything? Did you follow everything, Vedant Pandey? Damn, that makes me a bit happy because I'm not here to give one-on-one lectures, right? I charge people for that. Oops. If we can't know that, can we know if we can have a odd length? It's like bits, right? Basis elements are like bits. So, So first they are telling this as a vector space addition. First they are telling XOR as a vector space addition. They are using vector space logic of basis. This is our algorithm, not so. What is this? What is this? If you can repeat it. Okay, we can also use that. See, guys, if our assumption is true that I don't know why am I typing instead of speaking. We can now check for basis. If you use some higher, if you use some higher, you get something big MSB. If you use only lower, you cannot get that MSB at all. But if MSB is already present, then you go further and check further. have a doubt. I have a doubt. After adding this, would MSB of basis vectors be same again? Because see, if we have if our thing matches with some basis vector, but then you after you sort it, we are adding that. Then we cannot maintain MSB is unique, right? So guys, we may have multiple basis vector with same MSB2, but choosing any of them will work probably. Choosing any of them will work. We add the final value of AI plus 1 after removing previous bases. This thing remains in AI plus 1. This thing makes sure our MSBs differ. Unlike this, we wouldn't forget bases. What about zero? What about zero? Ignore zero. Okay, ignore zero. Because zero can always be achieved by non-empty set of bases, right? I think it doesn't matter. It doesn't affect. See, if MSB doesn't there, that means that is a basis because you cannot obtain that. If MSB is already there, then you're making it smaller. Done. Here val becomes zero, or it would have been a basis element. Probably works, right? So now we will try to see is there an odd subsequence. Okay, how to sleep. See, see this thing. Okay, see this thing. Int c equals to zero. C XOR equals to 1. If val equals to 0, that means this can be represented using basis. And if it is not, that means that is basis, means that is odd number. Okay. Or I can keep this outside. Now, if C is 0, it won't happen here. Means if C is 0, means we have a value A of I that has been represented with odd even number of basis elements. Okay. If C is 0, odd subsequence equals to true. Int capital A equals to 0, let's say. Whenever you find a new basis element, I'll do L plus plus. Okay. Or I will do int PL equals to 1. PL, okay, it's just into 2, right? I can get into 2 by doing left shifts anyway. Yeah, now we are here. If there is an odd subsequence, okay, if k equals to n, see out XOR of everything. What XOR of everything? I think here odd subsequence definitely exists. Why? Odd definitely exists. Why? Guys, I will prove one thing. I will prove one thing. See, I will prove one thing. If k is odd, odd subsequence definitely exists. How? If it's not exist, means all all AI equals to odd number of BIs. Now, uh, 1 minute, give me time. Now take XOR of all. You have odd, odd up to so on, odd number of times, which will be odd. Okay, odd. And now both sides are odd. Both sides are odd, right? Means odd equals to 0. See, if k is odd, odd, if you bring this side, these are odd number of elements, right? Odd number of times odd is odd number of elements. So probably here you have 1 minute. XOR of odd all bases equals to XOR of total. This is odd, this is odd. So sorry, we don't have anything. Leave it. I don't think we have anything. Leave it. odd subsequence adding up to 0. L will be at least 1, I think, right? If all of them are 0, then we have an odd sequence adding up to 1. So then L will be 0 and this will be 0. So it works out. If all of them 0, then only L is 0. Otherwise, this is greater than 0. If that is greater than 0, this works. Fuck. The C should be outside, right? That C should be outside. Because finally C should be 0 for that to be odd. So that basis is not existing. So we will add this val as basis and then we increase, we found new basis. Where is odd subsequence here? Where is odd subsequence? 2 is not equals to 2. 3. Okay. See, each basis comprises of some number of elements, right? I will call that CB, number of elements in each basis. Okay, maybe this guess will work. So number of elements involved in valve is what I want to know. Number of elements involved in valve. Okay. Number of elements involved in valve. So here we are involving one more thing, which is this value, and everything else are bases. And then we know what their answer is over here. This should be one. This should be one. Say zero. We came here. Base is already existing, so we came here. Cross me tomorrow, bro. Cross me tomorrow. I know it's difficult to understand this code because it's somewhere messy, right? But I like to assume I have understood what I wrote. It's intuition. This is intuition, I think, because I'm not thinking. I thought XOR would work because C is having CB of basis of j gives me number of a's in this. Okay, CB of basis of j gives me CB of j gives me number of elements in this. Number of elements in this. So now to calculate basis of j, I have collected so far before this. So far we collected these many CBs, and then we are sending this that side. This is one, so C cross one. And now to know what is this, we have to again calculate this or this. We have to find its value. So it comes back. So and then we have our this. This seems perfect. I'm ending the stream. Bye. Hey, Siddharth Tikekar, your ID was wrong. Nice, bro. Damn, bro, dominated resume is coming. Visualized resume is coming. What are you? Flex my muscles before. I'm not sleep. I'm not. It's not there. It's not there. Only apps are easy. Others are difficult. Bye.